My name is Andy Redman, and I am in charge of America's solution engineering for Progress Software, focusing on the Flowmon product line. Today, I'm going to be giving a demonstration of network performance monitoring and diagnostics, NPMD, and also network detection and response, NDR, in the Flowmon product. Before I get started, I think it's good to level set. From Gerald Combs, the Wireshark creator, the goal of protocol analysis is to give you truthful information so that you can make wise decisions. And this is really focused on both network performance analysis and also network detection and response. Gartner also says, and this is very interesting, that detection and response are more important than blocking and prevention. Quite interesting statements right there. So let's take a look at some architecture drawings so that you'll have an understanding of how the Flowmon product is leveraged. Flowmon encompasses two core aspects or two core appliances. One is a Flowmon collector. That's the brains of the actual Flowmon product. It has a number of software packs that are loaded into it that perform network performance monitoring, NPMD, and also network detection and response. There are additional modules that are provisioned on the appliance. Take, for instance, Flowmon Packet Investigator, which deals with actually capturing packets in flight and being able to analyze them. And then there's another pack which is called application performance monitoring. The two that we're focusing on today, of course, are NPMD and NDR. So the Flowmon collector is the brains of the operation. Flowmon also provides a Flowmon Probe, and I'll make this statement. It's a rather bold statement. The Flowmon Probe is the most powerful NetFlow exporter on the planet. And the reason for that is we've taken standard NetFlow, not V5, V9, V9, but IPFix, V10, and we've enriched the NetFlow capability substantially to have critical awareness of things like a lot of layer 7 based capabilities, TLS, a number of functions within the TLS layer that allows us to get very granular with respect to examining enriched or TLS-based encrypted traffic. Now let's talk about this diagram just for a brief second. So the Flowmon collector understands NetFlow. We can take native flow logs from any public cloud, AWS, Azure, Google, and we can convert those native flow logs into NetFlow. So these products, whether they're hardware or virtual, can reside in public cloud, on-premise, co-location, virtualized hardware, as I noted. We can also do something like VTAP, which is a port mirror within AWS, Google, and we can capture traffic from a VPC, virtual private network, and we can send that data directly to the Flowmon collector for analysis. The Flowmon Probe has integrated into it native Suricata IDS feed as well. So not just can we pull in real packet data, convert that to NetFlow, but we can take signature-based sources and inject those into the probe as well and send that to the collector for analysis. Now, we can take other kinds of flow data as well. We can take for instance, from a firewall, we can pull IPFix data into it. We can take NetFlow from a router. We can pull in SFlow from a switch, JFlow from like a Juniper router. One of the challenges with pulling in NetFlow sources into the collector is, the quality of the NetFlow is the critical important point, okay? And the ability of doing really forensic level deep packet inspection, the quality of your NetFlow is critically important. And this is why I made the statement up front that the Flowmon Probe is the most powerful NetFlow generator on the planet, because the source of truth, packets don't lie. And so if you can pull full packet off of a switch and you can harvest all the data that's coming into the Flowmon Probe, and then you have enriched capabilities from a flow standpoint, your ability to understand critical issues in a network, whether they be performance issues or whether they be security related cyber events, is essential. Let's talk about SFlow just real briefly. So SFlow, Yes, while we can ingest S-flow from a switch, that is highly sampled data. It may be 1 in 1,000 packets that's sampled. And so the capabilities with respect to performance monitoring, et cetera, are going to be highly limited. So you can see here north and south visibility. Well, we can operate within a virtualized environment, whether we're taking a full packet mirror or we actually install a probe or a collector within the VMware, Hyper-V, whatever environment to get that lateral traffic as well if we need to get nitty-gritty down to the, down to the individual VMs, et cetera. So this gives you an overall view of the kind of architecture. Now, from a scalability standpoint, we can have a distributed architecture. And what this looks like is having a Flowmon collector, which talks to a proxy unit. And it talks to these slave collectors, which actually do individual processing. And so you can take flow sources and you can point them to a single IP address for their destination of that net flow record. And that proxy unit will act as a load balancing agent to distribute the load between these slave collectors. Also, you can take a Flowmon probe and point that to the proxy unit as well. This is one type of distributed architecture which can be leveraged within very large scale environments. However, you may have a branch location type of configuration setup, and this branch location could be reflective of New York, London, Singapore, et cetera, or even local within one specific geography. The point with this configuration is you don't use a proxy configuration. You have these distributed collectors in these different environments. Now you can see here, I've got a collector in New York, London, and Singapore. However, I've got a single probe sitting here in San Diego. Well, what's the deal with that? Basically, the single probe, it doesn't store data. So if within the WAN connection between the Flowmon probe and the Flowmon collector, there is a break in communication, break in net flow is going to occur, and the probe does not store that data. The logic for having a distributed collector within a branch office, say, for instance, in New York, is the fact that it's capturing all the net flow for performance data, cyber attacks, those kinds of things locally to its respective region. If there is a break in that connection, well, while that is a problem, once that link is restored, that collector then can communicate back up to this master unit. And so all the analysis is done on the master unit. However, you can have a highly distributed environment to where you regionalize these collectors and you do analysis local to that particular environment. Let's take a look at the actual interface and we'll walk through it. So in this particular web user interface, we see that we have a dashboard that shows a number of different things within the dashboard. So this is our demo environment. Now, in my own personal environment, I have also a Flowmon collector with a probe setup. And the reason why I'm showing you this is because within this particular configuration, I can show you how you can easily populate dashboards. You want to monitor G Suite, Cisco WebEx, Google Meet, antivirus apps, ICMP, routing protocols, on and on and on. These are point and click provisioning to greatly speed the deployment of a collector, building dashboards that give you critical insight into a particular environment, and you've got the ability of adding customized widgets specific to the data that's important to you. So if you have an Active Directory set up with Exchange and you want to visualize the authentication request coming through a Kemp Loadmaster authentication engine, going back to Exchange through Active Directory, you can map that out within specific widgets and see how efficient the authentication requests are being serviced. So at a high level, we'll go back to the demo dashboard, and what you're going to see under the status page is how many flow sources are coming in, structure of the traffic as it relates to applications. So at the beginning, I mentioned APM, application performance management. We can look at different web application servers. We can look at SQL servers, MySQL servers, et cetera, and map the quality of that communication. We can also see in the status dashboard security-related issues, overall network performance, and this is a retransmission index. So for all of the sources of data that we're examining, we can look at the retransmission, the TCP retransmission rate, to see if we're starting to see issues with respect to dribbling errors because of a bad piece of fiber, copper, congestion in the network. Perhaps it's a server that's being overrun. We'll be able to see that kind of detail as well. We'll also see a structure of overall traffic. We can create alerts so that if we have multiple WAN links coming into our data center and we say, look, if we had a 60 or a 65% utilization on one particular link, it's time to start thinking about expanding that particular link from a 1 gig to a 2 gig to a 10 gig, or adding additional links for resiliency. Let's focus on NPMD. So NetOps and SecOps. The Flowmon product blends both NetOps and SecOps into a single platform. So I mentioned at the beginning a couple of times that the Flowmon Probe is the most powerful source of truth as it relates to NetFlow. It enriches standard IP fix. The quality of what you can get is critically important. Well, within NetOps, we can see how many devices are active at any one particular time. We can see the hosts that have top flows. We can look at hosts with top data transfers. And then I can dig down into that with a magnifying glass and open the monitoring center. So again, the dashboard gives you a high-level view of things that you want to look at a bird's eye glance. And then you can dig down into the monitoring center to get very specific with respect to traffic as it relates to hosts with top data transfers. And the first thing that you're going to see is just high-level statistics. You'll see this graph here that allows me to dig down into specific segments. I can right-click, tops, first flows, the first 20 flows, for example. And once I do that, what it's going to do is run some analysis, and it's going to give me a spit out down below. Now, it's important to note that I build profiles, and these profiles are built upon what kind of traffic am I interested in looking at? Where's my source? Is it a branch location, a headquarters location? Is it a load balancer that's actually offloading its NetFlow capability? Well, let's go back down. So we get a first output of what's happening here. We can see the source IP address. We can see the time of the first flow. We can look at the destination port, destination client, TLS versions, those kinds of things. This is looking at extended TLS. Let's go to the default output. Click process, and what we'll see here is an output that gives us different types of information: source IP, destination IP. With respect to the flow generation from the Flowmon Probe, we include layer 7 details like TCP flags. Those are important. So you can see if you've got an ACK, you've got a push, you got a reset, those kinds of things at a glance. Now, we can look at our list of flows. We can limit them to a specific time frame. We can dig down within a specific time frame. We can say, look, I want to sort by start time of flows. Now, I want to sort by bytes, because when I was looking at this dashboard, I wanted to see specifically who are the hosts with the top data transfers. So I can dig down into that, and I can sort that data based upon this particular IP address talking to this particular IP address has consumed 1.9 gig of traffic for this particular duration of time. So I can look very granularly and figure out very specifically who's talking the most and what they're talking about. I can look at what kind of source of TCP protocols it is. The granular capabilities with respect to the deep packet inspection, quite frankly, is brilliant. And so here's the takeaway. Instead of using Wireshark to capture traffic, if you can capture it when you can actually have the problem occur, if you can capture all the source of that traffic and the destinations of that traffic and all the different environments that those two endpoints or those one to multiple endpoints are communicating, that's very difficult to do. If you're talking about high-speed networks, when you're talking about 10 gig a second of traffic, capturing 1 second of traffic is massive. And then you need to use programs like SplitCap and other kinds of programs that allow you to break down those packets to do the analysis. This particular packet, because it's incredibly lightweight, about 500 times more scalable because it's enriched flow data versus full packet. You can take for instance, a full month, operate like a DVR. A problem occurred, dial back within this monitoring center dashboard and root cause what was the source of the problems incredibly quickly. So flow data is going to give you a full umbrella view of every single IP, every single endpoint in the environment, who they're talking to, and the quality of that discussion. Furthermore, you can dig down into extended performance. So take, for instance, extended network performance monitoring data. If I select that as the output of this data, I can see average jitter, millisecond delay, server response time, on and on and on. So I could see if it's a network that's causing the problem, or are the application endpoints that are serving up the applications, the servers that are hosting those applications, non-responsive. So very quickly, I can determine if the latency issue that Johnny's called me about is his problem, a network problem, or if the application is not performing in a timely manner. So that gives you a high-level view of application monitoring with NPMD. Now, if I look at SecOps, because remember, it's a blended platform, the foundation for me to be able to make good decisions about security events in the network is quality net flow. If I've got an umbrella view of everything that's happening in the environment, then I can start to apply some really slick logic on top of that anomaly detection capabilities. And this is where the anomaly detection ADS engine, which is the foundation of network detection and response, comes in. So looking at SecOps, I can start to see different types of anomalies. Okay, I can start to see behavioral based things that are occurring. Let me paint a picture. So I take my laptop, I go to the coffee shop, I click on a link that I should not have clicked on in my email, very slick malware. I don't know that I'm infected. I bring that laptop back to the company, and then I plug it in, or I connect to the wireless environment. Instantly, that laptop with the malware starts to call out to command and control outside of the environment. The system will flag blacklisted communication, as you can see down here. And instantly, I can make a response communication to a border firewall, take for instance like a Fortinet, and tell it to ACL that IP address before it has any potential to communicate further and do a TCP SYN scan, other types of port scans to look for high value storage mediums. That's where the data is, where the command and control is going to want to ransomware. But this particular dashboard gives you a high level view of events, categories, things of that nature. So let's dig down in. So clicking on that magnifying glass brings me to anomaly detection system, and you can see all the different modules within the system. So ADS, the part of NDR, I'll get a high level view of different methods that are being attacked or priorities based upon hot priorities, maybe not so hot priorities, and other things that are happening within the environment. So I can look, I've got a dictionary attack occurring. Well, I can look at the source IP address of that particular attack. I can see exactly when it was detected, the last update to it. Oh, hey, I'm scanning via RDP via port 3389, and this is the duration of that time frame. And here's my target. Here's the data feed. So as I mentioned before, when we were looking at NPMD, in the monitoring center, I could localize and logically go down into the environment to look at particular segments, particular branch offices, particular flow probe sources, other net flow sources, and get very granular with respect to the data feed of this particular attack. I can click on the event ID. This will tell me a high-level overview of what it is. It's a dictionary attack via the RDP protocol. How many times did this occur? Over what time frame? What was the average time frame between events? Here's the event source. Here's the MAC address of that. Guess what? I've actually got user identity. How can I do that? Well, the system allows me to pull in authentication logs and then map user ID to specific flow, specific IP address. So I can very quickly, not just with network performance issues, if I'm looking through various flows, I can map those to users, but who is the source of the attack? So I can not only signal via NDR, the border firewall, to ACL that, quarantine that IP address so it can't communicate with that blacklisted command and control center, but then I can easily figure out who is the offender, go to that device and mitigate risk. That's the brilliant part. And this is why Gartner has said again, detection and response are more important than blocking and prevention. Why? Because over 48% of all businesses within this country have already had data breach. And you know that far more than 48% have had someone, a threat actor within their environment. So I can look at the attributes. of this particular event. I can look at how many bytes were transferred, going in and out, the time of it, duration, the ports that were used. I can look at actually specific event evidence. And I can drill down into that evidence to see, okay, is there one single flow that's been communicated? Here we have 44 bytes, 199 times, and I can see every aspect of that communication, very in depth. And then because we're pulling in Suricata IDS, I can map that to IDS-based logic as well. Incredibly powerful. Now, this is looking at it from a high level. I can dig in from an actual events view because we do display graphs with respect to events. And I can look at a simple list and see from this particular time frame, the perspective is going to be a security issue. I can see different kinds of events as they come into the network. I can look at it by MITRE ATT&CK framework, which this is pretty brilliant. So I can look at initial access. What are the methods that are being used to actually get access to my environment? Behavioral patterns, those kinds of things. I can look at command and control communication, remote access software, using email, etc. And I can dig into each of those respective events. I can actually see if there's lateral movement within the environment, lateral transfer tool, high transfer events between these two particular endpoints. Exfiltration. Well, what we've seen with Flowmon is that typically what happens is when someone gets into an environment, they get a hold of a server, a database server, for example. What are they doing? They're chunking that data, and then they're attaching that data, 300, 400 bytes of packets, onto ICMP, random DNS domain detail, and egressing that data out of the environment. Once they've got that data, then they issue the ransomware or they take down the machine and ask for that Bitcoin or whatever payment they're after. We see exactly what happens based upon each respective event. If there is ICMP anomalies with payload, random domain stuff with DNS stuff, we capture that data and we map it by the framework, the MITRE ATT&CK framework. We also can look at it by host. And so we can say, look, we've got all these simple lists of all these different events. Then I can look at it by host and say, okay, I've got one particular host here. What types of things are they doing? Is it blacklisted communication? Is there exfiltration? Is there TCP SYN scans, port scans, et cetera, happening? And then I can look at it from an aggregated view standpoint. With respect to settings, I'm limited in capabilities in what I can show you here. But basically within the settings, I can determine if I do see blacklisted communication, what do I want to do with that? Do I want to ACL that and isolate that communication from occurring at the border? Do I want to actually take a TCP dump right on the probe? Because if we look back at this example, if I've got a probe here and I see an event where one of my hosts is talking to a blacklisted communication out in the wild, wild west, first of all, do I want to block it? Or do I want to capture that data for forensic evidence? So the Flowmon Probe has massive buffer built in, capturing traffic all the time within buffer. If I see the blacklisted communication occur, the collector says, I see this event. Based upon this policy hit, Flowmon Probe, start to TCP dump, capture that traffic for analysis. Once that event's over, that probe then sends that TCP dump in an encrypted manner to the collector. The collector does some initial analysis of that traffic, and it can be used, downloaded for further investigation within Wireshark, or if there's a need to use that for forensic evidence to an authority. Example use case, healthcare. In this example, we have Flowmon that's directly integrated with Dell Isilon storage. What happens in this event is that we've got communication. We're pulling flow into the collector from these various routers, switches, a probe in the environment. A threat actor enters the environment, and the Flowmon detector sees suspicious activity. We, via NDR, network detection and response, tell Superna, who is the platform that has been used for ransomware recovery and mitigation on the Dell Isilon storage. We tell that Superna software package that, hey, guess what's happening? We're starting to see this stuff. Mitigate this. Go ahead and issue a proactive snapshot at this point in time to mitigate the issue. if there actually is ransomware that does make it onto the endpoint.
I had a quick question for you about the form factor of the collector and the probes. So are there multiple, number one, do you guys sell that as a hardware appliance? Two, is there multiple form factors? And the third question, is there a virtual version of those that you can leverage?
Yeah, excellent question, Jason, and thank you for that. Absolutely. So the product is made on hardware, and it scales incredibly well. It scales up to 400,000 packets or 400,000 flows per second on each respective collector. And again, that's in a single collector, and that can be done. That could be leveraged across a very highly distributed environment. There are hardware collectors. There are virtual collectors, and they scale up to the limit, basically 10 gig of the underlying hypervisor host. Those virtual collectors have built-in probes into them, like a built-in probe that has a couple of probe ports. And so you can deploy this within a Hyper-V, a VMware environment. You can deploy these probes in public cloud as well, Azure, Google, AWS, et cetera. The virtual collector, let's just suppose that it's built into a VMware environment with the the collector's got the built-in probe that can be cross-connected. That can be the probe port can be a dedicated port on that virtual host, and that can be connected to a port mirror on an aggregation switch to harvest that data. Or you can actually do port mirrors within a distributed or standard virtualized environment switch, OVS, vSwitch, those kinds of things. So it operates both public cloud hardware and virtualized environments, giving you granular scalability across the board.
You mentioned Superna as an example of, I think you described it as a participating partner or something like that. What's the kind of scope of, because I love the idea of taking proactive steps with third parties, like increasing the logging level, taking that proactive snapshot. That's fantastic, because that's much better than just an alert popping up on a screen saying you're in trouble. What's the scope right now of like the number of integrations, or how easy it is to integrate that stuff, or who's creating them and why?
Yeah, that's a really fantastic question. And so we have a number of integrations already, like QRadar, IBM, Fortinet, checkpoints, other kinds of SIMs as well. So we have a full integration list. Now, that's a tricky one, right? Because the second that, and this is our integrations, basically, once we detect something, the product has the ability of leveraging scripting within it to communicate with these third-party devices to execute a particular action from a detection and response standpoint. And so why is that tricky? Well, then if that partner firewall upgrades the firmware, they change the process, et cetera. And so there's a process. So the vast majority, well, having broad scale integration becomes a challenge. Absolutely possible. There's an effort with doing that. Okay. And there's always wisdom in investing the time and energy to do that integration to mitigate those risks. Then there's the aspect of the SIM integration, for example. So we could have a significant amount of collectors out there running anomaly detection, and then sending those events by event ID to a SIM, and leveraging that SIM as the dashboard within the SecOps world to be able to then issue actions from that point. And so we integrate with log management tools and with third-party routers, firewalls, take for instance Supernas, to mitigate risk. So you've got that end-to-end visibility and the end-to-end capabilities. We never want to have to use Superna or a Nebulon or something like that. And that's why capturing in the forefront is a critical aspect of mitigating risk. But yeah, there are integrations. It can be challenging.
And this seems phenomenal. Like to piggyback off what John said, it's nice to be able to see something, be proactive, and have multiple steps. What I was trying to is, with all these integrations and the different partners and such you're working with, I guess the best way I'm framing this is how does all of that data get compiled, and then kind of how do you filter that per se to know kind of which data is pertinent? Is there any kind of like how does it recognize certain patterns and things of that nature? Is that data mostly already compiled and then you guys kind of frame it? And and then we see it a little better?
Yeah, that's a really good question. And so it's the collector's responsibility with a variety of different methods, machine learning, AI, heuristics, behavioral patterns. And we have, I'd say, a nominal 40, some of those that we, this is an effort. Flowmon's an effort well over a decade with respect to development, backed by about 50 or so different security professionals, research professionals from different universities, et cetera, that have poured into this platform to make it what it is. And so there are behavioral patterns. The anomaly detection, if you're looking at just network performance monitoring, the ADS engine, one of the key aspects of it is the behavioral patterns. So take, for instance, Gerard, if your normal behavior over the past 2 weeks has been, I'm consuming 256, 512K, up to a meg worth of memory, but you start shooting up on a regular basis to 5 meg, 10 meg, a gig whatsoever, we're going to instantly, based upon that behavioral change, advise you that there's something potentially happening. Why are we seeing so many data transfers occurring? You can dig into who's consuming from a social network standpoint the most data, who's looking at Netflix and those kinds of things, and map out from a behavioral standpoint, what a user normally does, and then how they're increasing their utilization. So good question. There's a variety of different methods that we've baked into the product, and the Flowmon collector is the one that stores that data, and it's basically first in and first out. So when you think about flows, we size our virtual and our hardware based upon how much storage you want to accomplish what. How much time frame in like that DVR do you want? Is it a month time frame that you want to scale back and take a look at what was happening to try and root cause, or do effective planning as it relates to increasing your internet capabilities, at the edge, at the data center, and those kinds of things. So there's a number of different techniques that are used.
What integrations do you have? You mentioned, automatically like mitigating a threat, via ACL. How do those integrations work, and what products are supported?
Today we have checkpoint integration. We've got integration with FortiGate, FortiSeam, Flowmon QRadar, log manager integration, Passler PRT integration. There's the product is fully API'd. Okay, and so there's a number of integrations that we've done to date. Those would be the high level of those. And here is the link that shows you the different integrations that we have today. And there are actual guides with respect to this is how you can accomplish the objective. It really depends on the third party that needs that integration. If someone's got a Palo Alto on the edge or another kinds of product, there's an effort to do that integration. Now, with respect to customers that don't have the talent within the organization, they want to leverage Flowmon to provide that level of integration, that can be done. There's a cost associated with that. There are also third-party solution integrator partners that provide that level of support as well. So there's a number of different integrations that we have today. Clearly, as I've mentioned, it's an effort depending on what you're trying to accomplish from a business and technical standpoint.
Could you please elaborate on the cloud side of things? What cloud providers are supported currently?
Yeah. Yes. Excellent question. AWS, Google, Azure. Now, today, AWS and Google have VTAP capabilities, okay? That allows them to do virtual tapping as in a port mirror today. Azure did have it, and then Azure has put it on hold. So there are VTAP capabilities, but the brilliant part of the product is that it can take in native flow logs. Right? And so you may have a massive environment, you're cost conscious, you can pull in native flow logs from Azure, Google, AWS today. The problem with that data is it's 1 in 10 sampled, and we're talking about Azure and Google. Now, I personally haven't found what Azure is publishing as it relates to their flow log sampling. There is an impact on sampling as it relates to the capabilities with respect to detecting certain types of things like port scans. If you don't get those packets within that sample, you may not harvest that data. This is why we believe the best flow that you can generate and consume in the collector is going to give you the best understanding and ability from a protocol analysis standpoint to mitigate risk and to understand performance.
You mentioned about having people taking their laptops and doing things with them and then bringing them back into the office environment. With a number of people working remotely, is there any component of this that looks at the endpoint side of things to contribute to some of that analysis, or is it really relying on everything being pushed through a corporate network where you have the full infrastructure in place?
Let's think about this logically. The vast majority of time, you're talking encrypted traffic where someone's VPNing in, they're doing a zero-touch type of clientless VPN access whatsoever, but it's encrypted traffic. And so your ability as a product to understand what's happening at these remote locations, the great thing about this product is it tracks if there's a flow that's generated within your network environment. Let me give you an example, and we'll broaden that answer a bit. With respect to large school environments, typically central IT is where the applications are published. You might have high schools, middle schools, et cetera, remote locations. Applications typically are not published there. So what happens is those branch locations, they reach out, they talk to central IT. There's a flow source that's generated that you capture. You can stick a probe at that remote location. You can stick a collector at that remote location, but you're going to see an endpoint communicating to an application within your environment. You will see who's talking to it, all the IP addresses, whether it's through the VPN or not. If it's through the VPN, you've got user authentication details that you can map to actual flows within your environment, and then you can see what are the endpoints that are using TLS 1.0? What about the client key length? You can look at the TLS in your environment and instantly map the applications that are breaking, best practice for cipher sets, TLS versions, et cetera. We can even map JA3 fingerprints, and we'll do this with respect to. We'll look at basically 5 layers of TLS communication: the version, the ciphers, the extensions, the elliptic curves, and the formats, and we'll produce this MD5 hash. This is our JA3 fingerprint. And so there are well-known published JA3 fingerprints for certain types of malware, Tor clients, and those kinds of things. And we map that detail out, and we can map the specific TLS versions, the specific JA fingerprints to the flow, back to that user, and figure out, has someone been compromised? And then make a decision about what I'm going to do about that at that point in time. Prevent them access, and then root cause analysis. So great question. In a distributed environment, it doesn't matter from where they are coming. We're going to see every single endpoint communicating within your environment. Thanks so much for allowing me the privilege of presenting Flowmon, network detection and response and network performance monitoring. Really appreciate the brilliant questions, very insightful. Please visit progress.com to learn more about the Flowmon product and how you can get a demo copy to evaluate for yourself. Thanks for the time.